Welcome to Direction Northeast. Hello, I'm Hannah Lake. This program is a presentation of the Communications Department of Northeast State Community College. This episode of Direction Northeast looks at space exploration and the successful Mars Rover program. We'll meet our guests and start our discussion following these messages.
My name is Aniravel. I'm an actress, and I got my start at Northeast State Community College. Just as acting truly allows me to express myself and learn new things about myself, my whole experience at Northeast State has allowed me to do that. I've found new interests, new hobbies, new passions that I would have never known had I not come here. Northeast State gave me a quality education, amazing friendships, but most importantly, it allowed me to discover who I want to be.
Join us on this episode for a trip to the space to the Red Planet. Your tour guide today is a member of NASA Mars Rover team. She's a scientist at California Institute of Technology. Dr. Melissa Rice, welcome to Direction Northeast.
Thank you.
So tell me how one goes from living in Seattle to working on the Mars Rover team and to being a scientist at Caltech. What were your steps to get there?
Sure. Well, my path was a little different because a lot of the people that I work with now, they knew from the moment they were born that they wanted to study space, and they were looking through telescopes when they were 4 years old and watching Star Trek, and I was not one of those kids at all. My first career ambition was to be a ballerina, and I went to college with broad interests in science, but also the humanities, and I didn't really know what it was that I wanted to do until I took my first astronomy classes, and then that's when the subject just reached out and grabbed me. So I knew that astronomy was what I wanted to do. I wanted to study things beyond the Earth, study the big questions. Who are we? Why are we here? Is there anyone else out there? And I heard a lecture when I was in college from a Mars scientist talking about the latest images that had just come down from Mars, from one of the orbiters around Mars, the Mars Global Surveyor. And those images showed that Mars once had sinuous valleys. Those are valleys carved by water that are proof that water had been on Mars for extended periods of time, and that there was a good chance that Mars could have been a place that had hosted life. And I thought that was the coolest thing that I had ever heard, that there might have been life, potential for life on our nearest neighbor, and so I decided that that's what I had to go study. So I went to graduate school at Cornell University and worked on the Mars Exploration Rover program, and since then I've been following in their footsteps, working on the Curiosity Mars Rover.
Do you feel like when you left Seattle you were adequately prepared for your journey?
You're never prepared for a journey to Mars, but yeah, I had a good, strong high school education, a really strong science program. But I didn't really know that Mars is where I would end up, and some days when I get up in the morning and I call into the NASA telecon where we're operating the rover on Mars, I still feel unprepared to be doing something this important and big.
Well, what did you find most difficult to get to where you are now?
What was the most difficult thing about getting to where I am now? Honestly, it was the physics problem sets. When I was an undergraduate and I knew that I wanted to study astronomy and astrophysics, I had to take a lot of physics courses with a lot of heavy math. And honestly, that got to a point where it was really pushing the limits of my abilities. And that was the greatest challenge, was just getting through that fundamental coursework. And some days, telling a rover on Mars what to do, that seems like the easy stuff.
So did you consider yourself a mathematics kind of person before you went into that coursework?
Yeah, I always liked math. I always loved science, but I wasn't really one of those kids who knows that they're going to be a scientist when they grow up. Yeah. So yeah, it was always a love, but and it came naturally at first, and then in college, as your classes get harder and harder, I realized, wow, this is really a challenge.
Did you ever have any doubts going through those courses that maybe this isn't what you wanted to do, or wanted?
Yeah, certainly. And I went to a small liberal arts college, so it had a strong science program, but there were all sorts of other programs in all of the humanities. And I took classes across the college and decided that, one moment I wanted to be a women's studies major, the next moment I wanted to be an environmental sciences major and save the planet Earth, and then I finally wound up on Mars.
Well, you talk about women's studies, and I know it's kind of changing now, but astronomy is probably a male-dominated field. I know it was at one point, or I'm sure it still is. Did that affect your efforts to get to where you are now, or have you noticed a glass ceiling, or do you think that's mostly been chipped away?
So a lot of the women that have come in the generation before me have done a lot of that hard work for all of us to make it possible for us to be in this field now, doing this kind of science at NASA, and to just be thought of as scientists and not necessarily women scientists. But I also had the great advantage that I went to a women's college. So when I was taking physics courses and astronomy courses and sometimes struggling with the coursework, I was in a very supportive environment of women. And when I went to graduate school and saw that in most of the rest of the country, when you're in a physics class at that level, you're more often than not the only woman in a class like that. Mm-hmm. I wonder if it would have been more of a struggle for me to have been, taking those classes, looking around and being the only woman that I saw. So I think it was really encouraging for me to be an undergraduate at a women's college and to not even be conscious of the fact most of the time that I was in a male-dominated field. It wasn't even an issue. The issue was just the science. And then it was later when I got to graduate school that I finally saw firsthand that this really is still a male-dominated field, even though it is just as easy for women to pursue this now as it is for men.
Well, you've worked with NASA's Mars exploration rovers. Can you give a little overview on that mission?
Yeah, the NASA Mars Exploration Program has the Mars Exploration Rovers, which are two identical twin rovers, Spirit and Opportunity. Both of those rovers launched to Mars in 2003 and landed in 2004. The Spirit rover kept going for over 7 years, but its mission ended a couple years ago. Opportunity is still going. It's almost 10 years later. In January, we're going to have the 10th anniversary party of Curiosity roving on Mars. And keep in mind that these rovers were designed to last 90 days on Mars.
Oh.
So having one of them still going 10 years later is an incredible achievement.
Yeah, well, what exactly happened to the Spirit rover, and where is it? What's its status now? Is it still on Mars?
The Spirit rover is still on Mars. We don't have a way to bring our spacecraft back. So Spirit is still there, and she will be for a long, long time, maybe until astronauts get to Mars someday and put a velvet rope around the Spirit rover and call it the Smithsonian Museum on Mars. That's what I hope. But right now, Spirit is still there on Mars, and she is non-operational. So what happened was that Spirit was driving along, getting dustier and dustier. These rovers are powered by solar panels, and the solar panels have to get a clear look at the sun to get enough energy to charge their batteries and keep driving. Now, these rovers were designed to last for 90 days. So in a span of 90 days, they're not going to get very dusty. But these rovers kept going past their 90-day warranty, and after a couple of years, they got really, really dusty. And Spirit got a few millimeters of dust caked onto those solar panels. And that had happened early in the mission, but then a big gust of wind came and blew the solar panels clean. So that happened a couple of times, actually, and that's why Spirit was able to live as long as she did. But after about 7 years, we had another thick cake of dust accumulated on those solar panels, and we didn't get that strong gust of wind that we were waiting for that had saved us multiple times before. We just never got a good gust of wind, and eventually Spirit's power levels got so low that she couldn't even phone home. It didn't help that Spirit was also trapped in a sand trap, and her solar panels were tilted away from the sun, and so she just got too little power to drive and eventually to even communicate with Earth. So that mission ended. But Opportunity, fortunately, is not in as dusty a place, and Opportunity is still growing strong.
Well, when did you join the team to work with those rovers, and what were your duties exactly?
Yeah, I came into the mission late, after their nominal 90-day mission was complete. So I started graduate school at Cornell in 2006, which was 2 years after Spirit and Opportunity had both been driving on Mars. And both rovers were originally expected to be long dead by then. But I was lucky enough to be able to work on the active missions, both Spirit and Opportunity, and to keep working on Opportunity through today. So when I got to graduate school, I was working for Dr. Jim Bell, who is the principal investigator of the cameras. The rovers have 2 eyes on the top of their masts, and those are the pan-cam instruments, the cameras. And so I was working with those cameras, and my role was called a pan-cam downlink lead, which means that every day the rover sends its new pictures down to Earth. And the pan-cam downlink lead, which was me at the time, would look at the new pictures and make sure that everything was in order, make sure that the camera was still functioning correctly, make sure that the pictures that we told the rover to take were the pictures that we actually got back from Mars, that the camera was pointed in the right place and that everything with the instrument was healthy. So that was my work, and that was really exciting because some days when I would get up in the morning and I'd look at the new images that had come down from Mars, I would know that I was the first person in the world to ever see a new vista from another planet. And that is a trip.
That's so exciting. Yeah. Well, what important information did those rovers give us about Mars?
Yeah, those rovers really revolutionized the way that we think about Mars and the complexity of Mars. So we sent them there knowing that there had been water on Mars, knowing that there had been rivers on Mars before, there had been lakes on Mars, but we really didn't know the details about the type of water that was there. And we didn't know much about the geochemistry of the water, and we just had never taken a close look at some of these minerals that are still on the surface of Mars that had formed in water billions of years ago. And so with the Spirit rover, we learned that there were a much wider set of aqueous minerals. These are minerals that had formed in water on the planet than we had previously thought. We found carbonate minerals, we found hydrated silica, we found ferric sulfate minerals, and these are all minerals that form in hydrothermal environments. And so we found what we think is our first real discovery of a hydrothermal system on Mars, something that might have been like Yellowstone National Park on Mars. How long ago that hydrothermal activity was happening on Mars, we really don't know. It could be a couple million years ago, it could be a billion years ago or longer.
Huh. Well, you were also involved with the Curiosity rover, which launched in 2012.
Yeah.
How did that differentiate from the previous rovers?
Yeah, this was really the next generation rover. Curiosity, you look at a picture of Spirit and Opportunity right next to Curiosity, and Spirit and Opportunity look cute. Curiosity is big. It weighs 5 times as much. It's 2,000 pounds. And it doesn't have solar panels. So it doesn't have the black, shiny surfaces that are characteristic of the Mars exploration rover, Spirit and Opportunity. It's white, and Curiosity has a big rump. It has a big butt sticking up, and that's its nuclear power plant. Curiosity is powered by plutonium. And so we don't depend on the sun. We can drive in the middle of the night if we want. We can take pictures in the middle of the night. We can be completely caked in dust and have no effect on our power.
Well, awesome. What would you say your greatest success and greatest moment of failure is in working with that rover?
In the Curiosity rover,
yeah.
specifically? Well, I think the greatest success for me personally was taking the techniques that I had developed working with the cameras on Spirit and Opportunity and applying them to a new spacecraft. And so my research specifically is with the cameras and with the multispectral imaging capability of the cameras, which means that the camera's ability to see in wavelengths longer than the wavelengths that a human eye can see. And so I work with those cameras to look at wavelengths beyond what humans can see, to look for absorption features in the spectra consistent with water. And I had done that in my graduate work for Spirit and Opportunity, and one of the greatest scientific rewards for me personally with Curiosity was applying those same techniques to a new rover on a different side of a planet and finding new results about water on Mars there.
Awesome. Well, What are some of the problems that you've experienced with these rovers that you've worked with? I know I've read about communication problems, and you said like the dust storms.
The dust was a big problem with Spirit and Opportunity, and that one was just something that we had to live with every day. And we are always monitoring how dusty the skies are so that we can get an estimate of how much power we're going to have coming up. And so the dust for Spirit and Opportunity has been a huge problem. Another glitch that happened famously with the Spirit rover was one of its wheels stopped working about 2 years into the mission. Spirit had been driving along, and then one day its right front wheel wouldn't turn anymore. It was stuck in place. And it's really hard to drive forward when one wheel is stuck. It just keeps grinding into the dirt. So Spirit, for the last 5 years of its mission, drove backwards, dragging that dead wheel behind it. And that was really disappointing because these rovers drive pretty slowly as it is. But with a dead wheel dragging behind the rover, we couldn't drive on as steep as slopes. We had to go even slower than usual. It was really hard to avoid obstacles and to maneuver ourselves. So that was really tough. But what happened, Spirit said to have the best bad luck of any spacecraft was that as the rover was driving backwards, digging a trench in the soil with that busted wheel, every once in a while we uncovered something interesting from underneath the surface of Mars, serendipitously in that wheel track. And what we found were the white and yellow soils, the silica and ferric sulfate-rich soils that led us to the conclusion that there was a hydrothermal environment there. So one of the major science conclusions that came out of Spirit's mission is something we never would have been able to make if all 6 wheels had been turning perfectly. So sometimes a glitch can actually be a blessing.
Yeah. Well, I know those rovers are still, the Curiosity and the Opportunity are still going on, but do you have any idea what the next steps for the space program are?
Yeah, last December, NASA made its next big announcement for Mars. And what we are going to do next is send another rover that's very similar to Curiosity to Mars, a new spot on Mars in the year 2020. And that rover is going to be the first step in our attempts to send rock samples, pieces of Mars, from Mars back to the Earth. So what this rover is going to do in 2020, it's going to look like Curiosity, except it's going to carry what's called a sample caching system. And that's really just a container, so that when the rover drills into rocks, it can pick them up, put them into this container, and store them. We don't know how long we're going to need to store them, but the idea is that NASA's next spacecraft to Mars will land next to that rover, pick up those samples in their storage container, and launch them back to Earth.
Awesome. You said, I read that your team worked on Martian time. How does that differ from time here on Earth?
Yeah, the Martian clock is 24 hours and 39 minutes in a day. So that means that it's really close to an Earth day, but just different enough to really be annoying. So what it meant practically was that our day, when we worked on Mars time, which we did for the first 90 days after Curiosity landed, every day was 24 hours and 39 minutes long. So on day 1, Curiosity landed at 11 p.m. at night in California time. And so that's when my first day started, 11 p.m. So I worked an 8-hour shift on the Curiosity rover, and my first day of working on the rover was 11 p.m. to 7 a.m. Now the next day after that, I started work at 11:39 p.m. and went until 7:39 a.m. And we kept shifting around the clock like that. So we started in the middle of the night. A couple weeks later, we were working a normal human schedule, and then we would shift out of sync again back into the night schedule. And we did that 3 times. We circled entirely around the Earth clock 3 times. So I got to learn about all the 24-hour restaurants in my area, the best place to get a cup of coffee at 4 a.m., which Starbucks in the area opened the earliest. And I got to see the Los Angeles area alive at all hours of the night, which was kind of neat.
Yeah. What kind of value do you think our government should place on space exploration?
Yeah, well, not that I'm biased or anything, but I think it's of extremely high value. Our government is the only government that has ever successfully landed a spacecraft on Mars. This is a really unique capability that the government of the United States has right now. And it's not a given. It's not something that we're going to maintain forever. We have to keep working at it. We have to keep the team of experts at work at these NASA facilities and keep their skill set up and keep pushing the boundaries if we want to maintain this really unique ability to land spacecraft on another planet. This is something that we really have to keep sustaining if we ever want to get humans to the surface of Mars someday, if we ever want to get humans beyond the solar system someday, which we really have to do. We have to be thinking about how we are going to go from being a single planet species here on the planet Earth to being a larger presence in the solar system and beyond if we want human beings to have any extended existence. We know that it's only a matter of time before another giant asteroid collides with the Earth and we have an enormous extinction event like the one that killed the dinosaurs. That is something, it's only a matter of statistics. Eventually that will happen. Some natural disaster will threaten our species. And if we don't have another place to call home, that might be it for humans. So it's really in our long-term best interest to be pushing the boundaries, starting with robots on Mars, then going to humans on Mars, and then going to humans elsewhere in space if we really want long-term survival.
All right. Well, what is your role at Caltech right now?
Right now, my role is I'm called a postdoctoral scholar, which is a postdoc position, is a 2-year position, 2 or 3 years, between being a graduate student and getting your PhD and becoming a faculty member or a NASA researcher or getting a full-time position. So I'm in sort of an apprenticeship position. It's kind of similar to a residency position after you've gone through med school. So I'm at Caltech working on the Curiosity mission for 2 to 3 years, and then after that, who knows where I'll be.
Well, I saw that you taught a first-year writing seminar.
Yeah.
You covered topics such as, will humans live on Mars one day, and did Martian life ever exist? And I know that's kind of what interested you into doing astronomy, but what would your answer be to those questions?
Will humans ever live on Mars someday? I think it's only a matter of time. And it may not be in my lifetime, it may not be in your lifetime, it may not be in the lifetime of our children or grandchildren, but I think eventually humans will get to Mars, and they'll have to get to Mars once we as a nation and as a world start realizing that our Earth is a precious resource and it's not necessarily going to be around forever. But I really hope that that happens within my lifetime, seeing a sustained human presence on Mars. As for life on Mars, I really don't know. I think there's a possibility that there might have been very primitive forms of life on Mars sometime in its ancient past, and that possibility is what drives a lot of my curiosity in the planet Mars, and that's something that I really hope that we can answer. But whether it's true or not, whether life ever took hold on Mars, whether life is anywhere else in the solar system or the universe, I can't give you an answer to that. That's why I'm doing this work that I do.
What has been one of the biggest highlights of your career so far?
I think being in the room with 400 of the Curiosity science team members when Curiosity was landing on Mars and getting that news that the spacecraft had safely touched down, and then seeing the first picture that Curiosity took, which was a picture of its front wheel in contact with the surface. That was one of my greatest professional moments, because then we knew that all of this investment, a decade plus of investment in building this rover and getting it to Mars, and $2.5 billion of financial investment, that was all going to pay off, and we were going to learn something really exciting about Mars.
Well, do you have any role models that have impacted your career?
Yeah, I had some great professors in college who really were role models for me in showing me that they could be excellent scientists, but also just really nice guys too. So I was fortunate to be able to work with them. But in terms of looking up to scientists who were out there, it was always really inspiring to me to see women in space. So for example, Sally Ride, first American woman in space, was a role model who was able to show us that space exploration is something that humans do. It's not something that men do.
I also saw that you have referenced Carl Sagan before. Are you a fan of his also?
Yeah, definitely. He's a big reason why I'm doing what I do now. I read his book Contact when I was a senior in high school, and that was what first really got me thinking that maybe astronomy and science is the way I should go.
Well, I think you're a role model for many women right now. What advice would you have for young girls that are thinking about studying science or even undecided right now?
Yeah, I would say if you're interested in studying science, then never forget what it is that first excited you. Keep going back to that. If it was a book like it was for me with Contact that really grabbed me, keep going back and rereading and reminding yourself of that, because school can get tough, school can get boring. My job can get boring. Looking at pictures of Mars every day, sometimes I feel like, it's just another job. Gotta get up and go through these hundreds of images. And it can feel like a day job, but I have to go back to what originally inspired me and remind myself, yeah, this is awesome. This is worth doing. It's worth working hard for.
Well, you've obviously been very successful so far. What is your ultimate goal?
My ultimate goal? Well, my ultimate goal is to be working on the mission that brings those samples back to the Earth. Our next rover is going to Mars in 2020. It's going to store samples, and then there's going to be a rover after that that lands and collects those samples and launches them into orbit, and eventually they'll get back to Earth. And I think that's where the real amazing, philosophically mind-altering discoveries can potentially be made, is when we get those samples back to Earth and we can do definitive life detection experiments. That's when we'll be able to say, yes, there was life on Mars, if there was life in those samples. And so I think that has the potential to be the biggest moment in Mars exploration ever. And it's my goal to be a part of that mission that brings those samples back.
All right, well, thank you for being here today. We'll be back in just a moment to wrap up Direction Northeast.
My name is Brad Ketcherin. I'm a registered nurse, and I got my start at Northeast State. I chose nursing because it gives me the opportunity to take care of people. I know I'll always have a job, and it gives me the opportunity to travel, which I've always wanted to do. So Northeast State was a great start for me. I was able to get my associate's degree there and transfer to a four-year college to get my RN license. I had always planned on going to college, but I wasn't really sure where I was going to go. After graduating Northeast State, I can truly say it was a good decision.
That concludes our program for today. We talked about space exploration and the Mars Rover project with Seattle native Dr. Melissa Rice. Community is very important to the students at Northeast State Community College, and this program takes a look at a few of the subjects they find important. Until we meet next time, on behalf of the students, staff, and faculty of Northeast State Community College, I'm Hannah Lake, and this is Direction Northeast.